So let's do motion in a plane. First is vectors in motion in a plane. This is x-axis, this is y-axis, and a z-axis in a coordinate geometry. We're going to call it as I cap, the direction, a j cap and a k cap in the case of vectors. So I cap, j cap and k cap whose magnitude is always unity, which means 1. A j cap's magnitude is 1, a k cap's magnitude is 1. It's only called direction, which is along x-axis, y-axis and z-axis. Supposing you have a point which is called the position vector. The position vector is given by 1i plus 2j plus 3k, because the 1 comes from the x-axis, 2 comes from the y and 3 comes from the z. So 1i plus 2j plus 3k. The origin is 0i plus 0j plus 0k. Suppose I join these two, I get a line vector. So supposing this is point P and this is O, they ask me what find OP vector. It's x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. So it's 1 minus 0 into I, which is 1i, 2 minus 0 into j, 2j plus 3 minus 0 into k, 3k. So the formula is x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. The magnitude of an OP vector is root of the component square, root of 1 square plus 2 square plus 3 square, which is root 14. How to convert a vector into its unit vector? OP cap is the vector by its magnitude. Convert a vector into unit vector is the vector by its magnitude. So 1 by root 14 into I plus 2 by root 14 into j plus 3 by root 14 into k, because you have the vector and you have its magnitude, divide that and write, and that's how you convert a vector into its unit vector. So you understood all this. In the unit vector, these are called direction cosines. The components of i's, j's and k's, the numbers are called direction cosines, DCs, because you know the magnitude of this will be 1, because root of 1 by 14 plus 4 by 14 plus 9 by 14 will obviously be root of 14 by 14. That's why it's called a unit vector, because its magnitude is 1. And the moment the magnitude is 1, you call those numbers as direction cosines, DCs. When it is not 1, say in this, the magnitude is not unity, right? In this one, its magnitude is root 14. So then these are called direction ratios. The numbers before i's, j's and k's are DRs, and here it's called DCs. So direction, when the magnitude is unity, we call it as direction cosines. When the magnitude is not unity, we call it as direction ratios. The components are called like that, okay? So let's go to parallel vectors. Suppose you have a 1i plus 2j plus 3k. I ask you to write a parallel vector in a simple layman's language. It's lambda times 1i plus 2j plus 3k. A parallel vector will be simply a lambda, where lambda is any constant. Okay, so that's how we write a parallel vector. But theoretically, how do we say that? Suppose one vector is a1i plus a vector is a1i plus b1j plus c1k. Another vector, b vector, is a2i plus b2j plus c2k. Then if these two are parallel, the condition for parallel lines, condition for the two vectors to be parallel is a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda. This is the theoretical part of it. Okay. Otherwise, you can say one vector is lambda times another. Simple way of saying is one vector is lambda times another. The theoretical way of saying is a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda. Are you clear? Condition for two parallel vectors. So a vector is lambda times b vector. Okay. Now let's go to perpendicular vectors. Supposing there are two perpendicular vectors. Okay. So in that case, it's a vector is equal to a1i plus b1j plus c1k, and b vector is equal to a2i plus b2j plus c2k. If a and b vector are perpendicular to each other, then its dot product has to be equal to 0. Okay, I'll come to dot product. Dot product has to be 0, which means the condition is when a dot, you can only dot an I and an I, a j and a j, and a k and a k. So therefore it will be a1 a2 plus b1 b2 plus c1 c2 is equal to 0. The condition for two vectors to be perpendicular to each other. Dot product has to be 0, where you can only dot i's, j's and k's. So a1 a2 plus b1 b2 plus c1 c2 is equal to 0 is the condition for two perpendicular vectors. Okay, now coming to what is this dot product all about? What is this dot product? A vector dot b vector's formula is magnitude of A into magnitude of B into cos theta. Magnitude of A into magnitude of B into cos theta is the formula for A vector dot B vector. So supposing they ask me to dot A vector itself is 1i plus 2j plus 3k. A B vector itself is 2i plus 5j plus 9k. They asked me to dot these two. I'll write it as 1i plus 2j plus 3k with a 2i plus 5j plus 9k. And you know I can only dot an I and I, a j and a j and a k and a k. Why? Because cos 0 is 1. Whereas cos 90 will become 0. Therefore I and j will be perpendicular to each other. So I can never dot an I and a j. I'll tell like this. You can only dot an I and a I, a j and a j and a k and a k. So then if you're dotting an I and I square is 1. J square is 1, you know the unit vectors. So therefore 1 2s are 2 plus 5 2s are 10 plus 9 3s are 27 will give me 37, 39, which is a scalar. It's not a vector. The i's, j's, k's have disappeared. It's called a scalar. That's why dot product is also called a scalar product. Okay, where a vector dot b vector is magnitude of a into magnitude of b into cos theta. But I didn't do any of that here. When they asked me to dot it, I just dotted an I and I, j and j, k, because angle between them is 0, it makes sense. I got a scalar. The best example of a day-to-day life of a dot product is a work done. A force into displacement. The dot product of force vector and the displacement vector gives you work done, which is a scalar. Are you clear? So that's an example of a dot product. Are you listening?
Yes.
Okay. So let's go to cross. Dot product is over. Let's go to cross product. Let's go to cross product. The formula for cross product is a vector cross b vector is magnitude of a into magnitude of b into sine theta. What is hidden in a dot product? A cos theta. What is hidden in a cross product? It's a sine theta. But you should write an end cap next to it. Why? Because when you cross, you get only a vector, you don't get a scalar. That's why it's called a vector product. I'll show you why it's becoming a vector. Okay. So supposing they have given a vector to be 1i plus 2j plus 3k. A b vector to be 2i plus 3j plus 5k. Let's keep it like this. They ask me to cross this. A vector cross b vector is 1i plus 2j plus 3k has to be crossed with 2i plus 3j plus 5k. You can only cross an I and a j, I and a k. You can never cross an I and I.
Even if you cross, it will come
0. And we only cross an I and a j, I and a k, j and a I, j and a k, k and a I, k and a j. Okay. You can't cross an I, you can only dot an I and I, j and a j, k and k. Crossing one, you can only cross perpendicular vectors. What is perpendicular to I will be j and a k. What is perpendicular to j will be I and k. What will perpendicular to k is I and j. So you can only cross this because that's when you get sine 90 and it will be equal to 1. Because what is hidden in a cross product is sine theta. Therefore you can only cross what are perpendicular. And the simple rule for crossing is write an I here, j here and a k here. An I cross j is k. A j cross k is I. A k cross I is j. You have to go clockwise. But in case you are going to go anti-clockwise, it will become minus. For example, I cross k will be minus j. A k cross j will be minus I. What is the doubt? Tell me the answer. I cross j is what?
I cross j is k.
J cross k?
Is I.
I cross k?
I cross k is
Minus j. So like that we have to do. But to do it, it's very difficult. I can't be multiplying like that because I'll make mistakes. So I'll teach you a shortcut. Can I? A cross product, we are not going to follow this method, though we know this. I'm going to teach you a shortcut which is determinants way. So write like this. Put two determinants like this. Write I, j and k on the top. Write these numbers 1, 2 and 3. 2, 3 and 5. Like this.
Okay.
Then write it like this. Then we're going to solve this determinants. You know how to solve this determinant? Write I into minus j into minus j plus k into. And what am I going to fill up in the graph? When I write I into, I have to ignore this row and this column where I is. Ignore the row and column where I is and do top to bottom minus bottom to top. Multiplication. 5 2s are 10 minus 3 3s are 9. So top to bottom minus bottom to top. So 10 minus 9. Are you clear? If I am doing I into, you are supposed to ignore the row containing I and column containing I. and do top to bottom is 10 minus bottom to top is 9. So then 10 minus 9 is 1. Minus j into, now you have to ignore the row where j is, row and column.
So 5 minus
5 minus 6, correct? So 5 minus 6 is minus 1, with this minus 1 will become plus 1. Plus k into, which means you have to ignore that row and that column.
1 minus
3 minus 4.
So minus.
So therefore it's 3 minus 4. So then therefore it's 1i plus 1j
j.
minus
Minus
1k. And did you get the answer as a vector?
Yeah.
Yes.
That is what I indicated here as n cap. The answer is not a scalar here, the answer is a vector,
Only for dot product it's a scalar.
scalar. And you understand that when you write it, you have to write I into minus j into plus
Plus
k
k.
into. And then he hide the row and column and do top to bottom
Top.
minus bottom to top. And that's how you find the determinant. For me to calculate like this, no, using this is very, very difficult because I am capable of making silly mistakes. Anybody would.
Yeah.
And therefore, it's better to do it this way, determinants way.
Okay.
Are you clear with determinants
Yes.
way? Yeah. Okay. That's about it. So you understood what is a cross product. Suppose they ask me what is the angle between two vectors. Angle between two vectors. Suppose you have an A vector and a B vector. The angle between them is theta. They ask you this. You know, you can see the dot product formula. You can find cos theta with this. You know already A vector dot B vector is magnitude of A into magnitude of B into cos theta. Therefore, cos theta is equal to A vector dot B vector by magnitude of A into magnitude of B. With that itself, we get the angle between the two vectors.
Okay.
Suppose this is 1i plus 2j plus 3k. This is 2i plus 5j plus 9k. You're going to dot them. It will be 2 1s are 2 plus 5 2s are 10 plus 9 3s are 27 by magnitude of A, which is root of 2 square plus 5 square plus 9 square. Magnitude of B, which is 1 square plus 2 square plus 3 square. That will give me cos theta.
Okay.
Are you clear? That's how we find the angle between the two vectors. Are you clear?
Yes.
Okay. Why, you can ask me, why didn't we use sin theta? I can't use because there's an n cap. I can only use the cos theta's formula from dot product to
Because
get the
it's a
angle
scalar.
between the, because scalar it's convenient for me to juggle around and get a formula for cos theta, which is this vector dot that vector by magnitude of this into magnitude of that. Are you clear? Clear, Vikram?
Yes.
That's about cross product of two vectors. Okay. Next, so cross product. Next is about projection. Projection of one vector over another vector. Projection means supposing you have an B vector here and you have an A vector. They are asking you to project the B vector along the A vector. Angle between them is theta. It's simply B cos theta. Magnitude of B into cos theta. Why? Because you write what is cos theta. It's adjacent by
Height.
hypotenuse, which is B. Construct to right triangle. Cos theta is adjacent by B. Correct?
Yes.
And so adjacent is equal to B cos theta. So that's how you get a B cos theta. In a vector, if you have a cos theta, then it becomes a scalar. The angle has been taken into account. Then it obviously becomes a scalar. So that's B cos theta. A projection of B vector on A vector is B cos theta. You already know what is cos theta's formula. What is cos theta's formula? A vector dot B vector by magnitude of A into magnitude of B. In that case, magnitude of B get cancelled. Can you see A vector by magnitude of A is A cap, unit vector. The vector by its magnitude into B vector. So there are different formulas. A projection of B vector on A vector is magnitude of B into cos theta, or it's also A cap into B vector. See, supposing I am projecting a B vector on A vector, I only need the direction of A vector, so I can write only A cap. I am projecting only the B on A, so it's A cap dot B vector. Are you clear?
Yes.
And you should know that dot product is commutative. Dot product is commutative. Commutative, which is A vector dot B vector is the same as B vector dot A vector. But cross product is anti-commutative. Cross product is anti-commutative. A cross B is not the same as B cross A. It's a minus of B cross A. Are you clear with this? Yeah. So that's about being commutative and anti-commutative. So then what else? I have to teach you a triangle law of vectors. You're fine? Your neck is paining? Okay. Triangle law. Triangle law of vectors. Supposing you have a vector which is this A vector. You have another vector which is B vector. If you have a vector C vector like this, they are all taken in the same direction. The sum of it will be equal to 0. A vector dot plus B vector plus C vector is equal to 0 if they are represented by sides of the triangle and they are in the same direction. If three vectors in the sides of a triangle are in the same direction, the sum of the three vectors is equal to 0. Are you clear?
Yes.
Supposing this is A vector and this is B vector. If this is C vector, opposite direction, then you can say C vector is sum of A plus B. The third side is equal to sum of the other two sides, provided the third side is in the opposite direction. So this is known as triangle law of vectors. Are you clear? If it's a polygon also it applies. So supposing there's the A vector, this is B vector, this is C vector. Then the D vector in the opposite direction will be D vector is equal to A vector plus B vector plus C vector. That's known as polygon law. It can be any direction, any side. If they are in the same direction, then all of it will be equal to 0. Sum of it will be equal to 0, yeah? Polygon law. Next I am coming to parallelogram law of vectors.
The same thing?
Parallelogram law.
The same.
What is the same?
Like something that is similar to polygon law and triangle.
Yeah. Parallelogram law is a very important question which will come derivation. So supposing you have an A vector like this and you have a B vector like this. You're going to construct a B vector parallel to this B vector. And you know one vector is parallel to another vector is lambda times that vector. But its lambda is just 1 because the magnitude is the same. The magnitude is the same and it's not just parallel, you can write the same vector. So this is also B vector. You know Vikram, this is A vector and this is B vector. Yeah? Therefore the diagonal in the opposite direction will be C vector, which will be sum of this basically. Correct, according to triangle law. But I don't want to use triangle law, I want to use parallelogram law. So what I am doing is I am constructing, by construction I am constructing this into a right triangle. I am constructing into a right. Can you see a big right triangle there? Yeah? You know the angle between the two vectors is theta. Corresponding angle, then this will also become theta because the extension of A and B. Since cos theta is equal to, in physics whenever you have something like this, no, I say like this, anything which is slanting, it's a vector. You can break it down into a B cos theta and a B sin theta. நான் பசங்களுக்கு சொல்வேன் கொக்கரக்கோன்னு ஏதாவது ஒரு வெக்டர் இருந்துச்சுன்னா உடனே கொக்கரக்கோன்னு இருக்கா ஸ்ட்ரெயிட்டா இல்லையா உடனே இதுக்கு தீட்டானா இது B cos theta and this will be B sin theta. இப்படி தான் நீ வெக்டர் ரிசால்விங் யூ கோட் டு டு வெக்டர் ரிசால்விங் லைக் திஸ் வெரி வெரி இம்பார்ட்டன்ட். Any sum can easily be solved without using any formula using vector resolving. The vector resolving is what I do normally. My all sums that I solve is using vector entrance exam question vector resolving. So then may become very clear. Can you say B which is a kokoroko here? Kokoroko is a B vector. So then therefore this is B cos theta and this will become B sin theta. When you include a B cos theta and sin theta, obviously it's not a vector, it becomes a scalar. Okay, now take this right triangle. Can you use Pythagoras theorem to find what is C, resultant? You can call this as resultant R. Pythagoras, according to base square plus height square. Base square is A plus B cos theta the whole square plus a B sin theta the whole square. Base square plus height square. Expand this is A square plus B square cos square theta plus 2AB cos theta and so plus B square sin square theta. Can you see B square cos square theta plus B square sin square theta is just B square. So root of A square plus B square plus 2AB cos theta. This will be the value of the resultant in the case of parallelogram law. Clear?
Okay.
Come on, get up. Okay? Energy, Vikram. So you understood how to find the resultant of a parallelogram. I deleted it, which is a root of A square plus B square plus 2AB cos theta, where theta is the angle between A and B. Suppose they ask me, what is the angle the resultant makes with the first vector? This is beta. The angle the resultant makes with the first vector, which is A vector, we can do tan beta, right? Tan beta is opposite B sin theta by adjacent, which is A plus B cos theta. When I have sin theta cos theta, I am not supposed to write vector. When A is alone, I can write vector. So tan beta is equal to B sin theta plus by A plus B cos theta. Therefore, beta therefore is tan inverse of this answer, whatever you get.
Okay.
Opposite by adjacent. What is opposite is b sin theta. What is here is a plus b cos theta. Can you imagine?
Yes.
Yeah, so that's what it is. This is known as parallelogram law.
Okay.
Very important question. But Chettinad, what they will ask you, I can tell you now, they won't ask you parallelogram law, they'll ask you law of triangle. They'll ask you law of triangle. It's a sure question in your paper.
Okay.
Okay, law of triangle, what do we do? Draw a triangle ABC. I don't know much about Shraddha school. I have never dealt with Shraddha, so it's mostly Chettinad or Shankara or BVM. Okay, so then I know what comes in your school, triangle law will come.
Okay.
What is if you right, mark this angle as A, B and C. Opposite to A is the side A, small a, side. Opposite angle B is the side small b. Opposite angle C will be small c. Now what you do is, what is law of triangle? Law of sine. Law of sine and law of cosine. Law of sine is like nothing but A by sine A. The opposite side by the opposite angle. Sine of the opposite angle is equal to B by sine B is equal to C by sine C, and this is what you need to prove. And can you see there is a sine B? Take the sine B and construct that into a right triangle, so that you can write a sine B.
Okay.
A sine B will be opposite by hypotenuse. So sine B itself is opposite by hypotenuse, which is C. So opposite itself is C sine B. So go to this diagram and write C sine B. Done?
Yes.
Sine B is opposite by hypotenuse. So opposite is C sine B. Done. Now go to this triangle. Go to this triangle and write what is sine C. What is sine C? Is opposite by hypotenuse. Sine C is equal to opposite by hypotenuse, which is B, but opposite itself is sine C is equal to C sine B by B. Therefore, B by sine B is equal to C by sine C. We got it. Are you clear?
Okay.
Oh, you wanted me to do it. So, this kadachirtha. B by sin B is equal to C by sin C. But you still haven't got A by sin A. So, for which you take the same triangle, angle A, angle B, angle C. What is opposite is small a, what is opposite is small b, what is opposite is small c. And you want sin A. So, then construct a triangle like this, perpendicular, BM. So, that you can write what is sin A. What is sin A? Is opposite by hypotenuse, which is C. Therefore, opposite itself is C sin A. Now take this triangle and write what is sin C, which is opposite by hypotenuse, which is C sin A by A. So A by sin A is equal to B by sin B. Can you see this equation 2, and they both are equal?
Yes.
Because both of them has got a
C by sin.
B by sin B. In this case, I've got a B by sin B. Every time I do it differently, therefore it's A by sin A is equal to B by sin B is equal to C by sin C. That's all.
So in China they will only ask to prove this.
Oh, I made a mistake here. It's C by sin C. Yeah, that's what. Yeah, you're perfect. Okay, so that's what you get. Are you clear?
Yes.
So this is done. Then next is law of cosine. Law of cosine. What is law of cosine? Similarly, construct a triangle. What is law of cosine? First, you should know what is law of cosine. என்ன வேணும் தெரிஞ்சாதான் அதை prove பண்ண முடியும். To get what, you should know what you want. Supposing you have a vector, this is A vector, this is B vector, and you have the angle between them both. You can find the opposite vector. இது தெரியும், இதுக்கு நடுவுல இருக்கிற angle தெரியும்னா opposite vector கண்டுபிடிக்கலாம். Suppose you know this side which is A vector, you know this side which is B vector, and you know the angle contained between them, you can find this opposite side.
See.
That's what is law of cosine mean. And the formula itself is A vector is, you know this two vectors which is B and C. It's root of B square plus C square minus 2BC cos A, because angle will be A. Angle contained between B and C will be angle A. Similarly, B vector is what is other than B? A square plus C square minus 2AC cos B. What is C vector? Is root of B square plus A square minus 2AB cos C. This is what is to prove. So now take a triangle like this. You know this is A, angle B, angle C. And opposite to angle A is small a, opposite to angle B is small b, opposite to angle C is small c. If you know angle, look at this, don't look at the clock, don't look at the watch, this is A and this is C.
C.
And the angle between them is B. You can find what is B.
B.
Correct? That's the whole thing, right? So you know A vector, okay, now you have to construct a perpendicular like this, which is AM, and you know what is AM already? Sin B is equal to opposite by C, so then C sin B. Sin B is equal to opposite by C, so opposite is equal to C sin B. அப்படியே எழுதுறோம் C sin B.
Okay.
Once you know this side, let's do cos B because it's got a cos. You found sin B and you found this. You wrote a sin B, wrote it as opposite by hypotenuse, so opposite itself is C sin B. Now you write cos B. Cos B is adjacent by hypotenuse. So what is adjacent is C cos B. So what is this? This adjacent side BM, which is C cos B. You already know this whole length is A. So this gap will be A minus C cos B.
Oh.
Purida? A minus C cos B is this. Now you take this triangle. Use Pythagoras Theorem. Hypotenuse square is equal to root of base square plus height square. Correct?
Yes.
So root of C square sin square B plus A minus C cos B the whole square. So let's expand this. C square sin square B plus A square plus C square cos square B minus 2AC cos B. Can you see C square sin square B and C square cos square B will become just C square. So root of A square plus C square minus 2AC cos B. We got it? B. Very, very important law of cosine. I'm doing it once again for you. Okay, I'll do it in the recording itself. Is okay. What is law of cosine? If you know two sides and the angle contained between them, you can find the opposite side. So this is angle A, this is angle B, this is angle C, this is small a, this is small b, and this is small c. If you know this angle is theta, this is cos B, say cos B. These two sides you know, you can find B. B will be equal to root of A square plus C square minus 2AC cos B. In parallelogram law, there will be always plus. But in a law of cosine, you have a minus. That's the difference. Otherwise, the formula is the same. Can you see?
Yes.
So we're going to prove this. So you have to construct a perpendicular. And you know sin B is equal to opposite by hypotenuse. Therefore, this is C sin B. Now, what is cos B is equal to adjacent by hypotenuse. So adjacent is C cos B. Therefore, this gap is A minus C cos B. Now take this triangle, use Pythagoras Theorem, get the answer. Very, very simple.
Okay.
Are you clear?
Yes.
So then you don't have to prove everything else. You just have to say similarly, C is equal to root of B square plus A square minus 2AB cos C. And A vector is equal to, A is equal to root of B square plus C square minus 2BC cos A. Like that you can write all the similarly put edina podu.
Okay.
We don't want centum, let your teachers keep that 1 mark.
Okay.
Because we have not proved that. It's why to prove each and everything. It's common sense, right? So you know, understood what is law of sine, what is law of cosine, what is law of parallelogram. In a law of parallelogram, it's like if you know two sides, the resultant will be root of A square plus B square plus 2AB cos theta plus. In a law of cosine, minus will come. Okay, so and what is in a parallelogram, what is tan beta? The resultant makes is opposite by adjacent, which is B sin theta by A plus B cos theta. You're not listening there. What is tan beta?
B.
What is the opposite side of parallelogram?
Opposite side parallel.
When you construct it into a right triangle, there was tan beta which the resultant makes with the adjacent side. Tan beta is equal to B sin theta by adjacent will be A plus B cos theta. You getting there? B sin theta by A plus B cos theta is what is tan beta. Either imagine, I want you to imagine and say.
Tan beta
Tan beta.
is tan beta is equal to B sin
By
by A plus
B cos theta. Excellent. And therefore, you can find the angle the resultant makes with the first vector. Where beta is angle, the resultant makes with the first vector. So you're kind of very clear with parallelogram law, law of triangle, which is law of sine, and law of cosine. Okay. I shouldn't say law of triangle. Law of triangle is only A, C is equal to A plus B. So I should say law of sine and law of cosine only. Okay. So then next is. Now I can teach you now relative velocity concept. Yeah, but I'll do it later. So then what is next I should do is vectors is over. You know how to find, see, supposing reviewing some question in Aurora. Supposing there is an A vector which is 3i plus 4j. So there is a B vector which is 7i plus 24j. Find a vector having magnitude, find a vector having the same magnitude as B but parallel to A. Moment you write parallel to A, it is lambda times 3i plus 4j, or a 3 lambda I plus a 4 lambda j is this vector.
Okay.
But it should have the same magnitude as B. What is the magnitude of this? Is 9 lambda square plus 16 lambda square. Which should have the same magnitude of B vector, which is magnitude of B vector is root of 49 plus 24 the whole square, whatever that is. 7 square plus, it's root of 7 square plus 24 square. So therefore you can equate this with this because they both are supposed to have the same magnitude. Root of 9 lambda square, what is this? 25 lambda square is equal to root of 7 square plus 24 square. Squaring both sides,
Cancel.
you get a 25 lambda square is equal to 49 plus 24 sir? 4 to 8, 9, 4 to 8, 2 4, 576. So lambda square, therefore it's added this 9, 15, 8, 985 by 25, whatever that is, and a square root of it. Are you clear?
Okay.
Yes.
So what would this be? Can I cancel it with something?
25 and
Have I
9.
added correctly? 576 plus 49 to, something is wrong with my addition. 8 to 625. What am I doing? 576 plus 49 is just 625. So 25 sir. So lambda therefore is 5. It's plus or minus 5, right? You can take it and substitute it here.
Okay.
So that you get that vector itself. It's plus or minus 5 into 3i plus 4j will be that vector. You can take it in, you get a 15i plus 20j, or if you take a negative sign, it's minus 15i minus 20j. Can you see, they've written only one answer. They didn't put a plus or minus. You forget about it. But you understood. What was this question? A vector is given, a B vector is given. You have to find a vector which is parallel to A, which is this,
Same as
which has the same magnitude as B, and you know to find them. You can write it. Are you clear? Okay, next question in vectors. Okay, I think that is enough for you for now. You can manage with this. Okay, just manage with this. You know how to find a cross product of two vectors. You know how to dot two.
product.
You know how to find angle between two vectors. Yes. There's one question. If you know, it will be good. You know how to project one vector over another vector. Next is supposing you have a vector A vector.
Okay.
What was I about to say? No, one second. I'm trying to recall what I was talking. I forgot. One second. Okay, I got it. Supposing you have an A vector and a B vector, it's like this. A pen. See, look at this. These two are two vectors on the plane. I want to find a vector which is perpendicular to both of these, which is maybe this, anything is always perpendicular to both this and this. You just have to cross these two vectors. Cross this, you get a vector. If you cross these two vectors, you get a vector which is perpendicular to both A as well as B. If two vectors are lying on the plane, you want to get a vector which is perpendicular to both of this, you just have to literally cross this. So that's another moral of the story. You have A vector and B vector on the plane.
Okay.
So then if you cross A cross B, you get a vector perpendicular to both A and B. Suppose they ask you to find a C vector which is perpendicular to both A and B, you just have to cross A and B and you know how to cross it. That's all. Are you clear? That's all is vectors, okay? With this you can manage.
Yeah.
I'm not going so much in detail. I'm sure that is enough for you for now. And I taught you what is parallelogram law, what is triangle law. Yes? So all that is over. And next is resultant. Okay, the relative velocity concept. Okay, now I want to teach him what is relative velocity. Supposing there's a car A, which is going like this. This is a car B which is also going like this. The relative velocity of A with respect to B, if both of us are moving like this, no, together parallelly, I will when I talk to you, you will be coming along with me. Your velocity will be appearing to be lesser. கரெக்ட்? ரெண்டு ட்ரெயின் சேர்ந்து போகுதுரா, பக்கத்தில் போகுது, பார்த்தீங்கன்னா அந்த ட்ரெயினில் வந்து அவன் பஜ்ஜி சாப்பிட்றது எல்லாமே யூ கேன் see it. ரொம்ப என்டர்டைனிங்காக இருக்கும். இட் will be very exciting for you to watch through the window. Have you seen? But when a train is coming opposite, சிக்குன்னு போயிடும். அதில் இருக்கிற ஒரு மூஞ்சி கூட பார்க்க முடியாது. ஏன்னா the relative velocity is getting added. When the train is going in the same direction, the velocity is getting subtracted. It's simple logic da. Okay. இங்க பாரு, you are standing, I am running. Okay. You will get to see me, my actual velocity. But you also run along with me. For you, my velocity will be less. So when you're going in the same direction, relative velocity is lesser. This is the layman's way of saying. Okay. But in physics, velocity of A with respect to B is always a VA vector minus VB vector. The velocity of A is also in positive x direction. Velocity BB is also in positive x direction. So it's VA minus VB. But supposing A is going in this direction and B is going in this direction, then velocity of A with respect to B will be VA minus VB. It's subtraction only, but because VB is in opposite direction, it is going to become VA plus VB. That is how it is becoming an addition when it's going in the opposite direction. Are you clear? Clear? Yes. Okay. Now I want to talk to you about something that is me and Ritanya as an example. Supposing I am a particle P. Okay. Ritanya is a particle Q. Okay. We both are going like this. So, but because both of us are moving, for me, she will appear to go like that. She is going like this now, actually. But now it will appear to go like that. Purida? It will appear. So for me, she will appear to go somewhere like this. But I don't know. To get that, I have to construct a P in the negative direction, which is minus P. See, velocity of P is in the Vp. This is Vq. I have to construct a minus Vp, so that by using a parallelogram law, I can do this diagonal, which will give me her velocity which is appearing to go. Velocity of Q with respect to P. That will be nothing but the resultant of this parallelogram. And you know how to find the resultant of this is root of Vp square plus Vq square. No, Vqp is the resultant of a parallelogram, which is root of this square plus that square plus 2ab cos theta. If this is theta, this is 180 minus theta. It's root of Vp square. No, negative sign will go away anyway. You don't have to consider its magnitude. Vp square plus Vq square plus 2 Vp Vq cos 180 minus theta. You all know 180 minus theta is minus cos theta. Trigonometry. Cos 180 he will know because I took trigonometry for him yesterday. Okay. You have to come for extra classes later. Then
cos 90 minus theta is sin theta.
Yeah, this is even integral of 90. It's 2 into 90. Where cos will remain cos. And this is second quadrant angle. 180 minus theta is a second quadrant angle, while sin only is positive. So it's minus cos theta. Okay. So therefore this formula will eventually become Vp square plus Vq square minus 2 Vp Vq cos theta. It will eventually become like this.
Okay.
And this is very, very important. This is a derivation for relative velocity. Derivation for relative velocity. Are you clear?
Yes.
Want me to do it once again? So supposing I am going like this, which is particle P. Ritanya is going like this, which is particle Q. But for me, Ritanya will appear to go much far, and I don't know how far. So I have to construct a minus P, so that the Q and a minus P will constitute a parallelogram, and the resultant of this parallelogram will give me relative velocity of Ritanya with respect to P. And I can make this into a parallelogram where the resultant VQP is root of P square plus VQ square plus 2 Vp Vq cos, if this is theta, this is 180 minus theta, cos 180 minus theta. You can even leave it like this. This is how we find the relative velocity.
Okay.
So now coming to this, there's this, I'm going to do few sums which will give you a lot more clarity on relative velocity. Okay, so let's do this sum. Example 59 from Aurora. Okay, a boat is moving with a velocity of the boat is 3I plus 4j with respect to the ground. So velocity of boat with respect to ground is VBG.
Okay.
Ground, is it moving? No. Which means velocity of the boat will be the velocity of the boat with respect to ground. Because both are not moving, correct? Next, the water in the river is moving at the speed V water with respect to ground. So V water with respect to ground is minus 3I minus 4j with respect to ground. What is the relative velocity of boat with respect to river? Relative velocity of boat with respect to water is a question. Normally it's VB minus VW if it's along the straight line. But this need not be along the same straight line. I don't know. Yeah, maybe it is along the same straight line because the boat and the river are going in the same direction. So you know it's VB minus VW. VB is here, which is 3I plus 4J. Minus VW is here, which is minus 3I minus 4J. So 3I plus 4J plus 3I plus 4J, which is 6I plus 8J. That will be the relative velocity of boat with respect to water or river. Are you clear?
Yes.
Can I go to next sum? Is example 60 in Aurora, where the question is a particle P is moving along a straight line with a velocity 3 meter per second. Particle P, Ritanyasam, is 3 meter per second. Another particle Q is moving with a velocity 4 meter per second. Velocity Q, 4 meter per second. The angle between them being 30 degree. Find the relative velocity of Q with respect to P. Ritanya with respect to me, I know it will appear to be somewhere here, so I have to construct a minus Vp in this direction. And this will become her relative velocity. This will become like a parallelogram. So the relative velocity of Q with respect to P is here, and VQP according to parallelogram law is root of Vp square plus Vq square plus 2 Vp Vq cos 180 minus theta, which will be 150. Cos 150. Correct? Angle between the two vectors. What is cos 150? Is cos 180 minus 30. Cos 180 is an even integral. So therefore it is cos 30 and its second quadrant angle. So it's got to be minus cos 30, and cos 30 itself is root 3 by 2. So minus root 3 by 2 has to be plugged in here. So it's root of Vp square. What is the velocity of this particle? You know it's 3 meter per second, so 9. This is 4 meter per second, so 16. Plus 2 into 4 3s are 12, so 12 2s are 24. And this itself is minus root 3 by 2. So the 2 and 24 get cancelled. So it's root of 25 minus 12 root 3. Correct? And root 3 is 1.732.
Yes.
You can substitute that value and hence find the relative velocity of Ritanya with respect to me. This sum is the Ritanya and Malthianti sum. You can remember it like that. Okay. So then let's go to next sum. So the next sum is the 61st sum in Aurora. Like this, you should take Aurora and do certain sums. Not every sum, only certain sums. To a driver going east in a car with a velocity of 40 km per hour. This is east, this is west, this is north, this is south, correct?
Correct.
To a driver going east at a speed of 40 km per hour, a bus appears to move. Vikram, don't look at the watch.
Okay.
A bus appears to move towards north. Now appearing means that is the relative velocity.
Relative velocity.
Bus appears to move means that is the relative velocity itself. North with a speed of 40 root 3, which is relative velocity of the bus with respect to a car. This is velocity of the car. This is velocity of the bus with respect to car. Then the bus would have definitely gone like this, no? That is why it's appearing to go like that. So therefore, you know the velocity of the bus is definitely here. Yes or no?
Yes.
And can you see that the relative velocity will appear to go like that, correct? So then so this is relative velocity. Okay, can you see this is itself is a right triangle? Can you see a right angle here? Yeah, so then when you get a right triangle, which we don't use parallelogram law, because cos theta will become cos 90. Yeah, but theta is the angle between the two vectors, which is this actually. So what do I do here? Okay, let's see. Can I construct a parallel vector here, which is also VBC? Therefore, I get a right triangle.
Yes.
I know this is VC, this is VBC, and this is VB. Can you see a right triangle?
Right triangle. Pythagoras Theorem.
Yeah, I can just use a Pythagoras Theorem to find VB, which is root of VC square plus VBCD whole square. I don't need a parallelogram law in this because it's
Simply we can just
construction. You have to construct a VBC parallel to VBC and make this into a right triangle. So then you can find VB to be root of base square plus height square, which is root of
16,000.
40 whole square plus 40 root 3 the whole square. That's all. Are you clear?
Yeah.
Suppose they ask you to find the angle the resultant makes with the first vector. Remember the angle that the resultant makes with the first vector, it's called beta.
Beta.
The resultant is purple color angle. Which is the first vector? Which is going faster? Car. The angle the resultant makes with the first vector itself is 90 degree, right? Okay, maybe they are referring to the angle, which means they are referring to This is beta. Okay, then in that case tan beta is equal to opposite. What is an opposite? What is
VC.
What is an opposite? VC. By what is an adjacent? BC.
BC.
So BC itself is 40.
40.
By 40 root 3. 40 get cancelled. 1 by root 3 will come in which angle? 30 degree. Therefore beta itself is 30 degree.
So therefore this theta is equal to.
You understood how I am finding tan beta?
Yes.
Tan beta is opposite. You construct BC here also. So the tan beta is VC by VBC. So it's all construction. Vectors is so beautiful. You just have to construct and do it. Very beautiful sum. So let's go to next question. Is this 62nd question? No, 62nd I'll skip. Okay, it's very tough sum. So let's go something else. I need more sums in relative velocity. Let's do some book back sums in relative velocity. Okay. Here is the relative velocity. Book back NCERT guidelines here. Some important sum. It's a sum number 4.12 in book back. 12th sum in book back. Okay. Rain is falling vertically with the speed of with the speed of 30 meter per second. A woman rides a bicycle with speed of 10 meter per second in the north to south direction. Okay, north to south. So let's consider it like this. She's going like this.
Okay.
So you can consider this as, see, rain is falling like this, and north to south may be road, no. It can be anything. So you consider this as north and this as south for a change.
Okay.
You didn't understand that part. Okay, rain இப்படி வருதுடா. One person is going like that. That's all.
Or we can say the rain is coming at an angle.
No, given that rain is falling vertically, how can you say rain is coming at an angle?
Okay.
You are right, but here the rain is only falling vertically down with the தலைக்கு மேல மழை பெய்யுது. ஒரு பொம்பளை இப்படி வரா, இதான் நான் தான் அந்த பொம்பளை நினச்சி பாரு, இப்படி வரேன்டா, ஆட்டோமேட்டிக்காக இப்படி வர ரெயினுக்கு நான் கொடையை இப்படி வச்சாகணும். ஏன்னா நான் மூவ் பண்ணுறேன். When I am moving, the rain is also moving. There is a relative velocity. The rain will not fall vertically on my head. It will fall slanting because Ritanya is appearing to be in some other direction. Yeah, so since the rain is falling like that and I am moving like that, I have to keep the umbrella like that. எதிர்க்க வைக்கணும். நீ போனது இல்லையா மழையிலேயே? See, மழை கோணலா வந்துச்சுன்னா நீ கொடைய ஸ்ட்ரைட் அப்படி பண்ணி மூவ் பண்ணிட்டு மழை இப்படி அடிக்குது, மழை இப்படி அடிக்குது, நீ இப்படி போற, நீ மழை இப்படி அடிக்குது, நீ இப்படி போறனா you will hold it straight. That becomes the relative velocity. Relative velocity நீயும் மூவ் பண்ற, மழையும் மூவ் ஆகுது. There is a relative velocity. But இங்க வந்து மழை ஸ்ட்ரைட்டா கீழே விழுது. Lady is going in north to south, some random direction she is going. So she has to hold the umbrella. If she is going like this, she has to definitely hold the umbrella like this. அப்படிங்கிறது practically you know. The rain will not fall like this. Rain is going to fall like this. So therefore she has to hold the umbrella. This you know in practical life.
Okay.
So what you have to do is you have to construct this velocity of the rain. You have to construct it below, extend it below.
Okay.
So that will become the velocity of the rain. This will be the velocity of the lady. So the resultant is in this direction. Can you see a 90 degree? So you can do by construction, right? Moment you see this is velocity of the lady.
Okay.
So we can do velocity of the lady here also.
Yes.
And this is the relative velocity of the rain with respect to lady. Correct?
Yes.
And if you want to find the relative velocity, it's a question about relative velocity. What is the relative velocity of the rain with respect to women? Lady. Okay. So VRL. Can you see right triangle here?
Yeah.
So VRL is equal to root of V rain square plus V lady square. That's all. Because it became a part of a right triangle. No need of parallelogram law or anything.
Okay.
So root of, you know the velocity of the rain is 30 meter per second, 30 the whole square. Velocity of the lady is also given to be 10 meter per second. So it's 10 square, so you get the answer. Thus you get the relative velocity of the rain with respect to lady. But what is the angle now the rain is? Is this angle tan beta. இப்படி வந்த rain இப்படி ஆகுது. Slanting, straight வந்த rain இப்படி slanting ஆகுது. Which is tan beta. And what is tan beta? You can construct what is tan beta is opposite. This is also tan beta, which is opposite by adjacent. What is tan beta is VL, velocity of the lady, by velocity of the rain. What is velocity of the lady? 10. By velocity of the rain? 30. So 1 by 3. Therefore tan beta is equal to 1 by 3. Beta is equal to tan inverse of 1 by 3. Take the tan, so it become tan inverse of 1 by 3. Okay, they won't ask you this anyway, only they'll ask you relative velocity. But are you clear?
Yes.
So it's a very, very important sum.
Just a minute.
Sure. Next is sum. It's sum number 14 in book back. Next sum is the sum number 14 in book back. Sum number 14 in a harbour. Wind is blowing. Sorry, wind is blowing at the speed of. So velocity of the wind is 72 km per hour. And the flag on the mast of the boat anchored flutters in northeast direction. Northeast means this is north, this is east, and so this is northeast. Which means this is 45 degree, this is also 45 degree. Northeast means 45 degree. The flag in the direction flutter out, and the direction the wind அடிக்குதுன்னு அர்த்தம். See, ஒரு போட் வந்து நிக்குதுடா. ஹார்பர்ல ஒரு போட் நிக்குது. அந்த போட்டோட flag ஒரு எந்த டைரக்ஷன்ல இருக்கோ அந்த டைரக்ஷன்ல தான wind அடிக்குது. அதனால தான flag அந்த டைரக்ஷன்ல இருக்கு. ஏன்னா போட் இன்னும் நகரல. Boat is standing. So wind is blowing in the northeast direction also confirm பண்ணிடலாம். So wind ஓட direction is northeast, correct? So then if the boat starts suddenly moving, now boat is going to move, wind is also moving. What will be the direction in which the flag is going to flutter? It's going to not be northeast, it is going to be in some other direction. So then we have to find that what is the direction of the flag on the mast now. So initially Nalagoni, the boat is stopped. The flag is moving in the northeast direction, which means wind is also in northeast direction. And its speed is 72 km per hour. Suddenly the boat is moving and the boat speed is given to be 51 km per hour. Suddenly the boat is moving. Now the flag will not be in northeast because boat is also moving, wind is also moving, so there will be relative velocity, and that is the direction which the flag is going to flutter. So let's do this sum. The wind is blowing in northeast direction, right? So this is the velocity of the wind, which itself is 72 km per hour. The boat is suddenly starting to move in this direction. Yeah, the boat is starting to move. Wow, in which direction? If the boat starts moving to north, it is moving towards north. The boat is suddenly moving towards north at a speed of 51 km per hour. Now you know, look at this, like Ritanya and me. So it's going to be, wind is in this direction, boat is in this direction, so the wind will now go in this direction, further down. Yeah, it's further down. Therefore, I need to construct this one, which is in this direction, negative direction, which is velocity of the boat, which is minus Vb. This is velocity of the boat initially, this minus Vb. And this resultant will give me the resultant relative velocity of the wind with respect to boat. Flag the wind. The flag is also nothing but wind. Velocity of wind with respect to boat, and this is the parallelogram law. Can you see? And you know, the most important thing, Kanna, you know this is 45 degree. And you know this whole angle is 90 degree. And the angle between the two vectors now is 90 plus 45, so 135 degree. Correct? And therefore the relative velocity of V boat is root of Vb square plus Vw square. Relative velocity, right? Minus. Relative velocity will always have a minus sign. Parallelogram law will have a plus. So 2 into Vb into Vw into cos 135 degree. And a cos 135 degree itself is cos 180 minus 45. And a 180 is an even integral. 180 is an even integral. So it will be cos 45 with a negative sign because it's second quadrant, which is minus 1 by root 2. So Vw is equal to 51 square, 72 square, 51 the whole square plus 72 the whole square plus 2 into 51 into 72 into minus 1 by root 2. Just cancel all this and get your answer. That will give you the relative velocity of wind with respect to boat. How easy the sum is. Are you conceptually very clear?
Yeah.
This sum is also book back. Book back is always very important. So there are two book back sums which I have done in relative velocity. Are you clear?
Yeah.
So then I will go for, I'll just go for the general sums, which is like they'll ask you such sums wherein in a circular path. This is not relative velocity, it's a normal sum. There is a circular path in which the particle P is coming to Q. A distance will be this arc length, which is 2 pi r by 4. distance, but displacement will be, displacement is this chord distance, which is r square plus r square. PQ is equal to root of r square plus r square, which is root of 2r square, which is root 2r. So you understand what is the distance and what is the displacement. Displacement is just the shortest distance between P and Q, which is just the chord, which is root of r square plus r square, which is root of 2r square, which is root 2r. But the distance is the entire perimeter divided by 4. So it's pi r by 2 is the distance. They might ask you what is the distance and what is the displacement. They'll ask you velocity and speed. Speed is nothing but distance by time. Velocity is displacement by time. So depending on that, if the time has been given, you can find the speed. And are you clear? Such sums are very important. Supposing the particle starts from P and comes back to P, the displacement is 0. So then therefore the velocity will also be 0. Correct? But supposing the particle distance means is 2 pi r. Distance means is 2 pi r, and you will have a velocity, which is itself 2 pi r by t. Do you understand? Therefore the distance will, yeah, okay. So I have taken only selected sums in this. Next is projectile. After this is the second part of the lesson, which is the projectile. So let's talk about a projectile. Projectile is something wherein you have a body So next topic is projectile. So supposing I am pushing somebody from the terrace. Okay, sorry. I am going to push them like that, giving only a horizontal velocity u. But eventually they are going to fall down like this because the gravity is going to pull them. What I am giving is only a horizontal velocity. It is called h and it is called range, horizontal distance. I am going to break it down into horizontal component and a vertical component. And use the formula s is equal to ut plus half at square here also, and s is equal to ut plus half at square here also. When I write s, it's horizontal, so s will become r, which is the range, is equal to the horizontal component of velocity is what I give initially, so ut. But there is no gravity in horizontal, so a becomes g and g becomes 0. Thus r is equal to ut. Let's come here. Instead of s, it's vertical, so you write h. There is no vertical component of initial velocity, so 0. But there is gravity, which is half g t square. So therefore you get h is equal to half g t square. You know from the first equation t is equal to r by, okay, you know from the first equation t, okay, you got, therefore t is equal to, what is t? T is equal to root of 2h by g. Take it 2h by g, a root of will give you time. This is time of flight. Time of fall will be t is equal to root of 2h by g. Take that and substitute it here. R is equal to u into root of 2h by g. This is the formula for range, and this is the formula for time of full flight. Time of flight. If somebody is being pushed like that, the time of flight is root of 2h by g. And the range is equal to u into root of 2h by g. You should memorize these formulas. Memorize it. Suppose velocity at any instant. Supposing a person is here. At any instant, his velocity will be tangential. And any two component prepare. And this will be two component, which is Vx and Vy. This is theta. Okay. And you know, can you see I can construct a vector Vy parallel to it, and I can write what is V. What is it? V is equal to root of Vx square plus Vy square, because it becomes a Pythagoras theorem. Yeah, what is Vx? V is equal to u plus at. In a Vx means horizontal component, I have initial velocity but gravity is 0. So then this becomes u square. Vy is u plus at, which is vertical. U is 0 but I have gravity, which is gt. So g square t square. Thus the velocity at any instant is u square, root of u square plus g square t square. Very, very important. So what are the formulas? A time of flight is root of 2h by g. The range, which is horizontal distance covered, is u into root of 2h by g. The velocity at any instant is root of Vx square plus Vy square, which is root of u square plus g square t square. Not only this, they will ask you to prove that the trajectory is parabolic. Trajectory means path taken as a parabola. How to prove that? Okay, consider at any instant of time the particle is here. At any instant of time t, which is at a distance of x and which is at a distance of y. Okay, now to prove that trajectory, this is the first step, x and y. Then you're going to write s is equal to ut plus half at square, where s can be written as x and s can be written as y. If it's this is horizontal and this means it is vertical. Do you have a horizontal velocity? Yes. And do you have a time? Yeah, t. Gravity is not there, so this becomes 0. So x is equal to ut. Correct? Come here. This is vertical. S is equal to ut. You don't have a velocity, but you have a gravity, half g t square. You know t is equal to x by u. From here, therefore substitute it here. Y is equal to half into g into x square by u square. Can you see y and an x square shows that it's parabola? Y and an x square shows that it's a parabola. Parabolic equation, polynomial ax square plus bx plus c. If y is equal to x square, it means it is parabolic in nature. So y is equal to g by 2u square into x square, where this is the coefficient of x square, shows that it's parabolic in nature, and you should know this formula. You should bug up this. G by 2u square. Y and an x square will be there. That's all. Next is, supposing somebody is throwing the ball like this, like a bowler, throwing the ball, then the trajectory will be like this.
Yes.
This is called initial velocity u. This is theta, so you will have two components, which is u cos theta and a u sin theta. Correct? You have a horizontal component as well as a vertical component. This is called height maximum, where at the topmost point the velocity will be 0. You know that.
Yeah.
Topmost point the velocity is always 0. That's why it's coming down, and you should know the time of ascent is equal to time of descent. These are the basic things in life that you should know. Time of ascent is equal to time of descent, and the velocity at the topmost point is equal to 0. So to find that, let's find the time of flight for half the flight. Time of half flight. Okay, to find the time of half flight, you know the velocity is equal to 0 there. So can we use v is equal to u plus at? So v is equal to u plus at, and the velocity, final velocity is 0. And when you say final velocity is 0, it means you are taking the vertical component. That's why the velocity there is 0. It's on the topmost point, which means it's vertical. So initial velocity is u sin theta. Vertical velocity is u sin theta. Will there be a gravity? Yes. Minus g into t. Because the ball is going up, gravity is going to be negative. Therefore, this is time of half flight. So time of half flight is u sin theta by g. So v is equal to u plus at you took, because v is 0 at the topmost point, and t is the time of half flight, gravity is g minus g, and initial velocity is u sin theta. So thus time of half flight is u sin theta by g. Time of full flight is time of ascent is equal to time of descent, so 2u sin theta by g. Double it. Correct? Now height maximum, let's find the height maximum. So you find time of half flight, you find time of full flight. Let's find height maximum, which is like s is equal to ut plus half at square. S is equal to ut plus half at square, where s you are repeating it as height maximum. So which means it's vertical component again. U will be u sin theta into t. Yeah? And t will be time of half flight. Time of half flight. H maximum is u sin theta into time of half flight. You just found it to be u sin theta by g. Therefore, is u square sin square theta by g is the formula for height maximum. Are you clear? By using the formula s is equal to ut plus half at square, that's when s can be written as h. And moment you replace s as h, it's vertical component. Vertical component initial velocity u sin theta into t. Gravity will also h maximum. What happens to gravity? H maximum is the vertical component, right? Ut plus half at square, you have that also, right? One second, let me do that. So you're going to write, let's use v square minus u square is equal to 2as and replace s as h maximum. Correct? H maximum. Let's write this as 2g with a negative sign, because the ball is thrown up, the gravity is pulling down. You know, you have a final velocity which is on the topmost point, which is 0. And the initial velocity is sin theta component, which is u square sin square theta. Therefore, h maximum is u square sin square theta by 2g. I'm sorry, what I did previously was not correct, because I ignored the gravity. I can't ignore the gravity. See, when I can do it even in that method. If I'm going to put s is equal to ut plus half at square, and replace S as h maximum, u sin theta into t, I took it as t half, correct?
Okay, yeah.
Minus half into g into t half the whole square. And it's getting complicated if you use this formula. Instead, let's use v square minus u square is equal to 2as,
Okay.
and you get the answer immediately, which is the time of half, which is the height maximum,
Okay.
which is u square sin square theta by 2g. Are you clear? Next is range. How to find range? Range formula, again s is equal to ut plus half at square. Range is the horizontal component. Is u cos theta into time of full flight, which is 2u sin theta by,
Lost.
what is the time of full flight? Is 2u sin theta by g. And the horizontal component do not have gravity.
Zero.
So it's 2u square sin theta cos theta by g. And you should know in trigonometry 2 sin theta cos theta is sin to theta. Remember Vikram? Sin to theta. You know the action sin to theta is 2 sin theta cos theta. So u square sin 2 theta by g is the formula for range.
Oh.
I'll do it once again for you. Very, very important.
Okay.
Okay, the trajectory in this case, no yawning, it's going to go like this. This is height maximum at which the velocity itself becomes 0. This is the whole range. Yeah?
Yes.
Don't feel sleepy, just answer. This is u. This is u. This is theta. So this will be u cos theta, and this will be u sin theta. You have both the components here.
Okay.
You can only first find the time of half flight by taking velocity as 0. So you use the formula v is equal to u plus at. V is 0. You, when I write v as 0, it means vertical. Vertical component u will become u sin theta minus gt. T will be t half. Hence t half will be u sin theta by g. Time of ascent is equal to time of descent. So time of full flight will be 2u sin theta by g will be time of full flight. Done. Then height maximum. I told you to use the formula v square minus u square is equal to 2as, where velocity is 0. When I write height maximum, it means vertical. So it's u square sin square theta minus 2g into h maximum. The h maximum therefore is equal to minus get cancelled. U square sin square theta by 2g is the height maximum.
Okay.
Let's calculate the range. S is equal to ut plus half at square. The moment I write it as r, it means horizontal, where the gravity is not even there.
Zero.
And u cos theta into t. T is time of full flight.
2u sin
Yeah, u cos theta into 2u sin theta by g. So it is 2u square sin theta cos theta by g. At 2 sin theta cos theta is sin 2 theta. So u square sin 2 theta by g will be the formula for range.
Okay.
Now they'll ask you to prove it's parabolic. They'll ask you to prove that this is parabolic. Last one.
We'll take any
Okay,
point.
you have at any point of time. Excellent. Summer sharp. Ah, come on. This is தூங்குற லேட் இல்லைன்னு நீயும் சொல்லிருப்பேன். This is x and this is y. Be competitive. Be competitive. Okay. This is x. This is y. Again, you're going to use the formula s is equal to ut plus half at square and break it down as x and y. X is equal to or y is equal to. When I take x is equal to, it's horizontal. And u will become u cos theta into t. There's no gravity.
Plus 0.
In horizontal, there's no gravity. Thus, you know, t is equal to x by u cos theta. Correct?
Correct.
Let's do y is equal to u sin theta into t
Okay.
minus half g t square. You have to prove it's parabolic. So you got a y, you need to get a x square. You can substitute this here. So y is equal to u sin theta into x by u cos theta minus half into g into x square by u square cos square theta. This is a sure derivation that will ask you in Chettinad. Sure question. Every year this paper you have this question. I will teach you once again. X into this is sin theta by cos theta is tan theta.
Tan theta.
Minus, can you see x square? What is the coefficient? G by 2u square cos square theta. So thus you have an parabolic equation.
Okay.
So I'll teach you this once again.
Yes.
You're throwing like this.
Okay.
Trajectory is like this.
Yes.
At any instant of time, this is the distance x and this is the distance y.
Y.
I'm going to use the formula s is equal to ut plus half at square, where you will write it s as x and x as y.
Okay.
X as x means it's horizontal, x as y means it's vertical. Is equal to horizontal component of velocity is u. This is u means this is u cos theta. and this will be u sin theta, correct?
Correct.
So horizontally u cos theta into t. There is no gravity in horizontal. Vertical s is replaced as y, it will be u sin theta into t, but there will be gravity, which is minus half gt square.
Okay.
To get this parabolic, you need a y and a x square.
Oh.
So substitute t as x by u cos theta from this equation, substitute back here.
Oh.
So y is equal to u sin theta into t is x by u cos theta minus half into g into x square by u square cos square theta. Sin theta and cos theta will become tan theta, u and u will get cancelled. So y is equal to x tan theta minus x square g by 2u square cos square theta. So then therefore it's parabolic.
Oh.
Are you clear? Very, very important derivation. Just be done with it, and then it's not over. There is also a circular motion, right? There is also a circular motion. Here, yeah, this is there. This derivation is like really, really important. Really, really uniform circular motion. This is like damn important portion. Uniform circular motion. Okay, you should know basic things in this, okay? Basic thing in physics is a linear velocity is r times angular velocity. அது என்னன்னா, supposing you are asked to run straight, it is so easy to run straight, you will run. But if somebody asks you to run around a tree, circular path, you have to change your direction, it is going to be difficult for you. That's known as angular velocity. சுத்தி ஓடுறது பேர் angular velocity, straight ஓடுறது பேர் linear velocity. So the linear velocity is greater than angular velocity, and the relationship is v is equal to r omega, where r is the radius of the circular path. Similarly, a linear acceleration is r times angular acceleration, whereas an angular momentum is r times linear momentum, opposite. And in the fan, the momentum is so fast. Angular momentum is something that is acting vertically above your head. It is so fast when you can't compare it with linear momentum. So in a rotational motion, angular momentum is greater than the linear momentum. That is not there now, but for you to know, these are basic things in physics. A linear velocity is r times angular velocity. A linear acceleration is r times angular acceleration. But an angular momentum is r times a linear momentum. This is a common sense in physics. And we are going to derive that only. To derive that, what are we going to do? A uniform circular path. What is the speciality about uniform circular path? The speed is constant, but the velocity only changes because its direction changes. So speed is constant and the velocity changes because its direction changes. Okay, that's known as uniform circular. Uniform circular path is a path where the speed is a constant, but its direction changes, and so the velocity changes. Are you clear? Okay, so then that's what it is. And let's take 2 points. Okay, let me redraw this. Let's take a point P here. Let's take a point Q here. Let's take a velocity to be Vp, and let's take the velocity to be Vq here. Let's mark this as center of the circle. This is radius and this is radius, correct? Okay. Now, what am I going to do? Just to prove that linear velocity. Okay. Can you see that this angle is a theta? This angle is a delta theta or a theta, angular displacement. And you should know from mathematics that theta is equal to L by R. Theta is equal to L by R from trigonometry, where theta is in radians, is equal to arc length by radius. So in this case, theta will be arc length by radius. And then let's take the arc length to be delta S. Let's take the arc length to be some displacement delta S. Let's take the angle to be delta theta. And you know delta theta is equal to delta S by R. Applying this formula. Yeah? Dividing both sides by delta T. Dividing both sides by delta T. A delta theta by delta T is equal to 1 by R. Radius will not change. Delta S by delta T. You know, it's like d theta by dt is equal to 1 by R into ds by dt, which is nothing but angular velocity. Angular displacement by time is angular velocity is 1 by R into linear velocity. Thus, therefore, linear velocity is R times angular velocity. You understand? This is common sense. How do you prove that? Take this diagram. Theta is equal to L by R, from which you write delta theta is equal to delta S by R, dividing both sides by delta T. 1 by R is anyway a constant, right? So you get this. Are you clear? Next is to prove that acceleration. Linear acceleration is R times angular acceleration. Just take this and differentiate it. V is equal to R omega. Just differentiate dV by dt is equal to R into d omega by dt. Which is linear acceleration is R times angular acceleration. Done. Just take this and differentiate it, that's all. dV by dt is linear acceleration, d omega by dt is angular acceleration alpha. Chumma differentiate it, you get it. So you got proof number 1 and proof number 2. These are the two proofs which are very important. The third proof is like really important. What is that proof? Let's take the same diagram. You know this is VP and this is VQ. Yeah? And this is the center, this is 0, and you're going to construct two vectors. A VP like this and a VQ like this. VP like this and a VQ which is parallel to this vectors. And you know this will be, according to triangle law, it will be, let's see, this is the resultant, right? Delta V, which is in this direction. Triangle law, this is the same direction, this is an opposite direction. So you know VQ is equal to delta V plus VP. Same direction and opposite direction will be addition of these two. So delta V therefore is VQ minus VP. Are you clear?
Yeah.
Write this first statement. Then you go for here. We are going to use similar triangle. Between this and this we are going to use similar triangle. This delta S we are going to treat it as approximately this delta S. According to similar triangle, this side by this angle is equal to, okay, this side by this side, okay. What is this side is V. This side is R. Correct? Radius. V by R is equal to this side by this side. Okay, let's say similar triangle I've got to use. Similar triangle. PQ. Okay, this side. Delta S by delta V. Correct? So you know it's a delta. Okay, let's see. This is delta S. Okay, let me do it in color pen. This is delta S. A delta S by R is equal to this side delta V by B. The magnitude of VP or BQ is just V because the constant speed, only the direction is changing. So you write this statement using the similar triangle. The statement is very important. So now you can divide both sides by delta T. Divide both sides by delta T. You get a delta S by delta T with a 1 by R is equal to delta V by delta T with a 1 by V. Correct? And you know this is 1 by R into delta S by delta T itself is V. And delta V by delta T itself is A by V. Thus A is equal to V square by R. Very, very important. Centripetal acceleration is always acting towards the center. In a circular path, the derivation for an acceleration which is always acting towards the center is nothing but V square by R. How do you do this? It's like this.
Okay.
And the centripetal acceleration and the velocity are always perpendicular to each other in a circular path. So that's A, and you know mv square by R is centripetal force. This is called centripetal acceleration. Centripetal acceleration, and a mass into acceleration is force. Force is equal to m into A. So mv square by R is known as centripetal force, which is acting towards the center. Are you clear? This derivation till here is very, very important. This is for a uniform motion. But supposing it's non-uniform motion, the velocity is not the same. The magnitude of the velocity speed is not the same. In that case, the acceleration is not acting towards the center. In that case, acceleration will not act towards the center. So this kokuroko nirka, therefore it will get broken down into two components. One is towards the center, which is known as the radial component, and one is tangential, which is known as the tangential component. So you have a radial component and a tangential component, correct? And can you construct this into a triangle, and you will get a right angle triangle because the radius and tangent are perpendicular. Therefore resultant is A is equal to AR square plus AT square. The tangential component whole square plus the radial component the whole square in the case of a non-uniform motion. Are you clear? Where the acceleration is not pointing towards the center, so it's like a slanting line which is kokuroko, so you have to break it down into two components. One is a radial component, other is a tangential component. Are you clear till here?
Yes.